Alright, so your form may be modeled as a uniform rod of length 0.4 meters and of weight 15 newtons free to pivot about your elbow. Your biceps is connected to your forearm at a point 0.040 meters from your elbow as shown. Determine the force that your biceps must exert to maintain your forearm in equilibrium at an angle of 30 degrees below the horizontal. Alright, so we see it's an equilibrium problem, so we can start thinking about our torque ideas immediately. And we know in equilibrium, the sum of the torques equals 0, F net equals 0, and that each torque will be equal to R times the perpendicular component of the force. So let's look at this, and we want to assign our pivot point, and I think the most useful pivot point is going to be the elbow. We know something about these forces, and we don't know anything about the elbow, so it's going to be most useful to assign that as a pivot point, and it makes sense if you consider how the arm works. So the weight we want to draw in, and it's acting at the center of the uniform rod, straight down towards the center of the earth. We know that it's equal to 15 newtons. So let's label the R, 0.2 meters. And now I believe we can start to set up this sum of the torques expression. So sum of the torques equals 0, and it'll be T torque of bicep plus torque weight. And we can even make a note that the torque of the weight would pull it clockwise, so that's going to be a negative torque. So we can think about that going forward. And now let's fill in the components of this. So R for the biceps is going to be 0.040 meters times the perpendicular component of the force of the biceps. So that's going to look something like this. And we want to know this perpendicular component right here. So we're going to have to use some trig. And, we already know this angle is 30. So this angle must be 60. And so then this one must be 30 as well. And this is the adjacent. And our unknown is going to be this hypotenuse. So let's fill it in as F biceps times cosine of 30. And now for the weight. So the R is going to be 0.2 meters. And again, we're going to have to do some trig. So the perpendicular component, the weight force, is going to look something like that. And so what's this angle? Well, we've determined that this angle must be 60 because this forms a right angle and this one's 30. So parallel lines, so this one must be 60. And now again we're working with 30 in here. And you might be able to tell that just by looking at it, but sometimes I like to just draw it out to prove it to myself. And so we actually know our weight force, and so it'll be 15 newtons times cosine of 30. And it's going to equal 0. And so now we can look at this, and we can just put this around here and say that this is negative, because it's going to be a clockwise torque, so it's by convention a negative torque. So if we solve this out, we wind up getting, I believe, F biceps is equal to 75 newtons, and that'll be upwards. so it'll be positive 75 newtons.